There's a good way to remember the years we have a leap year.
Yeah.
February 29th, the years we elect a president in the United States.
Well, there you go.
So that's in November. Yep, every 4 years, right? So tomorrow, February 29th.
There are some quirks here, though, and we'll go into the history of the leap year, the leap day, because our special day is coming up tomorrow. So let's go over the why behind it. It does have a little bit to do with science and specifically astronomy. So a year is defined as one revolution around the sun, the time it takes for our Earth to make that orbit. And is it 365 days? Well, not exactly. It's 365.2422. Couldn't make it easy. It has to be just that decimal right there. So if we didn't have leap days, you subtract that from the 365 days that a normal year is, non-leap year you have that difference, 0.2422 days. And that's about 5.8 hours missed each year if we weren't going to have a leap day. So without the leap day, in 100 years, our calendar would be 24 days off, and that adds up more and more centuries that you go on. So the solution, add 1 day every 4 years. As Kevin mentioned, on the election year, presidential election year, you go from 28 days in February to 29 days in February. So that yearly average is now 365.25 days when you average it out over the 4 years. So the problem's solved, right? Well, again, not exactly, because you take that 365.2422 days that it takes for the Earth to revolve around the sun. Again, we're short, we have a little bit of extra here. So that's 11.2 minutes too much each year by doing the leap year every 4 years. So with this in place, in 100 years, our calendar would still be 18 hours off. So in order to get it as precise as possible, leap year kind of follows this hopscotch here, where we skip a leap year if it falls on the start of a century. So in the year 2000, we did not skip the leap year unless that year is divisible by 400. So the yearly average is now pretty darn close to the actual amount that it takes to go around the sun, 365.2425. So 1700, 1800, 1900, we skipped the leap year. 2000, we didn't skip. And kind of going on like that, again, unless that century mark is divisible by 400. So with that kind of hopscotch rule, we're just down to a couple seconds here that were too much each year, 26 seconds too much. And at this rate, it would take more than 3,000 years to be 1 day off. So this is the best method that we've kind of developed. And it took a little while to get to this point. But let's review again that revolution around the sun is called the solar year or the tropical year. That's 365.24 days, that 5 hours, 48 minutes, 45 seconds extra that makes this a little bit complicated. Whereas, again, the common year is just 365 days. We're a quarter day short. But then on the leap year, we have that extra day, 366 days. We kind of add up the quarters that we've been missing to compensate there. So let's go back in time here with the Roman calendar before 446 BCE. The earliest calendar system from Rome, lunar calendar, kind of followed the phases of the moon, and that dictates the months, essentially. That's kind of a relic that we still use today. So it was only 10 months at first, 304 days, 61 days were kind of unaccounted for in the winter here. Eventually they moved to 12 months, but it was based on, again, the cycles and phases of the moon, and it was only 355 days, this Roman calendar. So it was 10¼ days short of the actual solar year, and there was this messy kind of patchwork of these calendars where the elected officials in Rome were adding these extra leap months in to catch up within their terms to kind of extend their terms. So then you have Julius Caesar in 46 BCE in Rome, and he worked together with astronomers in Egypt to devise this Julian calendar. It was solar-based, counted the year as 365.25 days. So once every 4 years, that extra day was added. But it was kind of an overcorrection. There was too many leap years, like we talked about, because the solar year is actually 365.242 days. So by the 1570s, a slight difference, 11 minutes, 14 seconds added up each year, and it was out of sync by the solar year by about 10 days by that point. So it drifted away from the astronomical events like the spring equinox and the winter solstice. So in 1577, Pope Gregory the 13th, he developed the Gregorian calendar. He appointed a commission, eliminate those extra 10 days, get back on schedule. So he tweaked the system of the leap years. Leap years every 4 years, except on those centennial years that aren't divisible by 400, and it kind of gets us back on track there in that step-letter format. So between 1582 and 1927, we had to transition to the Gregorian calendar. And some Catholic countries were abiding by the Pope, like Spain, Italy, and Portugal. They adopted that calendar right away. They eliminated those 10 days. So October 1582 was a short month, whereas some other countries, like the United States, waited until September of 1752 to adopt the Gregorian calendar. And again, it was a shortened month by about 11 days. So interesting how we had to kind of chop off those days to get back on track and use the Gregorian calendar, which is what we use today, that most accurate one with the leap years and kind of having that hopscotch with the century years. So if we didn't have the leap year again, 700 years from now, we would be behind by 6 months. So that would really throw things off with holidays and the seasons and whatnot. And then one last note here, weather records are interesting for leap days. Because in Bismarck, each day we normally have 150 years of climate records going back to 1874. But for February 29th, we only have 36 years. Divide that 150 by 4. So record high for tomorrow is 69, set back in 1992. Record low, minus 17. Again, these were set on leap years because those are the only years we have, February 29th. So an interesting history of how those leap days came to be with the different calendar systems and what we use today.
Boy, before you had mass communication, it must have been very, very confusing when they made those major changes.
Yeah, to get the right calendar for the whole country.
Yeah.
Interesting stuff.
It is fascinating. It all comes down to literally seconds, and you got to keep it all straight, right? Otherwise, everything gets out of whack.
And it's
really
still
quick.
not perfect.
Right.
Like, off by a couple seconds, but over thousands and thousands of years, not going to make a big difference.
Next time we'll talk about the leap second. I think they added one maybe 10, 15 years ago. I'll have to research that, but a leap
But we don't
second.
have to add a whole extra day to disrupt our lives based on that.
That's right.